Okay, so we are going to do practice test number 3. All right, so we have our calculators ready. Remember, we'll type all this in on our calculator. We're going to take full advantage of this period because this is our last chance. Here we go. Number 1. How many outfits can I make if I have 10 jumpers, 12 shirts, and 2 pairs of shoes? You paying attention, Caleb? All right, what's your thought on that, guys? Just multiply them all together. That's exactly right. And so the answer to problem number 1 is 10 times 12 times 2, because I have 10 choices, 12 choices, and 2 choices, and the answer then is what, 240? Remember, you gotta answer it with a number. How many ways can 8 people be seated around a bonfire? 7 factorial, because if we're in a line, it's however many we've got factorial, but if we're in a circle, it's 1 less factorial. So the answer is 5,040. How many ways can you answer 10 multiple choice questions if each question has 3 options? So think of that for a minute. We have 10 questions, and each of them has 3 choices. What are we going to do? Jacob? Exactly. We're going to multiply 3 times 3 times 3 10 times, right? So 3 to the 10th. I don't know what that is. That's probably a pretty good.
59,049.
What?
59,049.
59,049. How does that sound? Okay? Perfect. Everybody with me so far? Pretty easy. Now, we're going to be dealt a 5-card hand. It's a probability 5-card hand. So my denominator is going to be 52C5. Got that, folks? Probability, that's my denominator. Now, what's my numerator? What do I want? I want 4 hearts. Okay, so think about that. What's that going to be? 13C, not 5, 4, because I only want 4 hearts, right? So that's going to be 13C4. But, Gabe, you're kind of onto something. Think about it now. It's a 5-card hand, so I need 5 cards. But only 4 of them can be hearts. So there they are. There's the 4 hearts. What's the other card going to be? It's going to be not a heart, right? How many not hearts are in the deck? What? I think somebody said it. 39. And you need 1 of those. So here's the deal. This problem is a little tricky. There's been one on every practice test though. So you know this is going to be on your test, this kind of question. It's a 5-card hand. 4 of them are hearts, which automatically means the 5th card can't be a heart. So you're going to pick 4 from the heart pile. There's 13 hearts. And you're going to pick 1 from all of the other cards. Does that make sense to everybody? All right, let's type it in. See what we get. Just a second, I'll catch up here. I got 0.0107. Does that sound right?
Even when it's on the test, will it specify when to round, or do we just round?
It's going to have the same direction. So round to the nearest 1,000. So nearest 1,000, thank you for reminding me to read the directions, would be this. the probability of being dealt a 5-card hand? Okay, same denominator, guys. Same denominator, it's a 5-card hand. Remember yesterday it was a 4-card hand? So then it was 52C4. And it's all face cards. Which is the first thing you gotta figure out. How many face cards are there? Well, there's 3 for hearts, and 3 for diamonds, and 3 for spades, and 3 for clubs. So altogether, there are 12. And I need to pick 5 of them. So what's my numerator? 12C5. Now, this is one where you have got to be paying attention. You see what I'm talking about? Look at the end of your number. What's at the end of the number? And that means it's scientific notation. So we're going to write 3.047 times 10 to the negative 4th. You have got to pay attention to those E's on these card problems. Now, obviously they don't happen all the time. They didn't happen on our first one, but they happen a lot. Number 6, read the problem and tell me what you are thinking about in terms of a strategy. Venn diagram, very good. This is going to be a Venn diagram problem because what's happening? We have 80 students altogether. All of them enjoy matrices or vectors, so every single one of them. So there's nobody out here. Everybody's in the circles. 48 love matrices. 42 love vectors. And we want to know how many like only vectors. So basically what we're saying is we want to figure out this number right here. Would you agree with me? Those are the only vector people. So how do we go about that? So kids, remember there's 80 kids in the room, right? How many votes do you have here? 90. Okay, well that's a problem, right? So if there's 90 votes, but there's only 80 kids, what? 10 of them voted twice. Well, if this whole circle, I don't really need this one, I'm really going to do it. If this whole circle is 48, then this would be 38, right? And if this whole thing is 42, then this would be 32, right? So the answer to the question is 32. How many like only vectors? You good? All right, number 7. I have 10 Republicans and 7 Democrats. And I'm going to pick 5 of these and 3 of these. All right, so what do you think about this? What might be your strategy for this? What'd you say, honey?
10C5.
Yeah. She says I've got 10 potential Republicans and I'm going to pick 5 of them. Now, she said C. Would you agree this is a C or should it be a P? It's a C, because if I am just picking 5 people to be on my committee, does order matter? No. So there's a group of 10, I'm picking 5. And there's a group of 7 and I'm picking 3. As we're working through these problems, remember, you're gonna have to do this by yourself. So did the Venn diagram make sense to you for this problem? And does this kind of strategy make sense to you? We've learned a lot of different strategies. And somehow we gotta know what to do when. Did you get 8820? 8,820? Remember, we're all typing in, right? Come on, put your lanyard on. Henrik, where's your lanyard? Leo, Taylor, get it out so I can see it. Alright, next problem. How many ways can 4 unruly students be lined up in the hall? 4 factorial. So the answer is 24. Makes sense to everybody? What if I made them stand in a circle? 3 factorial. How many ways can I give 5 identical pencils to students in a class of 8? So I've got a handful of pencils here, they're all the same, and I'm gonna give them away. 5C5, 8C5, any other ideas? 5C8? Now let's talk about that, Gio. Now, you'll catch yourself because your calculator won't do it, but think about what this says. This says there are 5 kids and I'm gonna pick 8, right? It's gotta be the big number first. I like 8C5. I think the answer is 8C5. Now, what if, instead of giving away 5 identical pencils, what if I were giving away a marker, an eraser, a pencil, a pen, and a calculator? That'd be 8P5. Because if the presents are the same, it's a C. But if the presents are different, it's a P. Listen, what if I were picking a committee of 5 from these 8 people? 8C5? But what if I were picking a president, vice president, secretary, treasurer, and councilman? Then it would be P. If you are picking for the same prize, the same job, the same role, it's a C. If you are picking for different prizes, different jobs, it's a P. All right, is that settled in? Okay. All right, what's next? How many 10-letter words can be formed from the word calculator? All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? I told you in the problem that even if I didn't, you would count up the letters. So how do we start? 10 factorial. But I put that division line on there because as I was writing the word, I noticed we have duplicate letters, right? Repeated letters. So what do we got? 2 C's. What else do we have? 2 A's. 2 L's. Now each letter gets its own factorial. Is that it? And I know you're tired of hearing me say it. What am I going to caution you about when you type this in? You need parentheses around the bottom. Okay? You need parentheses down there. Ooh. 453,600. Number 11, What's your strategy here? What's your thought when you read it? It's gonna be a tree diagram. So you know your tree diagram is gonna look like this. And you're gonna write something here and here, and something here, 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 and here. Alright, so here we go. What's gonna go in these first boxes right here? Rain and not rain. Is there anybody who wonders about how we decided that? The question's asking about homework, so on the bottom is gonna go homework. Do you know homework? Come here, where's your lady? You got it on? Yeah, that's shut. Alright. Now, let's put some numbers in there. If it rains, the probability that Tim does his homework, so if it rains, homework is 65, so this is 35. Remember, every V has to add up to 100%. If it doesn't rain, it's 0.32 and 0.60. Remember, you have a calculator to do whatever math you need to do. You don't have to do anything in your head. There is a 10% chance of rain tomorrow. Find the probability Tim will do his homework. All right, here we go. What do I do? Here's one of the branches I want. Would you agree with me? This is doing homework. This is rain and homework. So 0.10 times 0.65. Or it could not rain and do homework. This branch right here. So that's 0.90 and 0.32. And since it's this or this way, what am I going to do to these two answers? Add them. Yep. So that should give us a nice little decimal. Did you get 0.353 as your final answer? Good deal. On the actual test, I spread that out a little bit more to give you more room to look. Okay, oh boy, number 12. Here we go. I'm gonna have to erase this. Everybody okay with the tree diagram problem?
How do we so label it as a decimal? Where do we use the decimal?
There's no label in the decimal. That's a percentage. So just leave it 0.353. Or you can write it 35.3% if you wish. That's it. All right, anything else before I erase that? Because we have the big problem to do now. Okay? Okay, so we need to expand 3x minus y to the 5th. Somebody tell me the steps we go through to do this. What do we do first? We write down the numbers from Pascal's Triangle. Remember that? What do we do after we get that done? We write down the variables, which are going to come from the problem itself. And then what's the last thing we do? Put down the exponents. Well, that's really not the last thing. Then we have stuff to simplify. Okay, so numbers, variables, exponents, and then clean it all up. Okay, so we need our numbers. We're going to get Pascal's Triangle. So I guess I'll do it right here. So start with 1, 1. Remember, you got to do this by yourself. You will not have the triangle. 1, 2, 1. this is the time to ask. If you are not sure where I am getting these numbers, please ask, because if you can't get the numbers, you're not gonna get the right answer, obviously. Start and end with a 1, and then we add to get the next row of numbers. Joshua, you got it? Now, why did I stop there? I mean, obviously I could keep going, I got extra room. Why did I stop there? Because I am expanding to the 5th power, which means I use the 1, 2, 3, 4, 5th row. So my numbers are 1, 5, 10, 10, 5, 1. Those are my numbers. Step 1 complete. Now, be careful. The components, the letters, the variables are 3x and negative y. Those are the variables in this problem. 3x and negative y. Look at the problem. 3x, negative y. This is not a subtraction, this is a multiplication. All right, what about exponents now? What do I start with right here? 5. Start with that number right there. And then this one will be 4, 3, 2, 1, 0. And then, same thing going the other way. And after I'm all done with that, I'm going to take a quick glance at it. And what has to be the case about my exponents? In each term, see how they add up to this number? I encourage you to mark out anything that's to the 0, because I just don't want you getting confused. Anything to the 0 is just 1, and since I'm multiplying, it doesn't have anything to add. Okay, so what's my first term? Be careful. If it's in a parentheses, it gets the exponent. So what is this first term going to be? 243 x to the 5th. How'd she get 243? 2 to the 5th, good job. All right, now be careful here, this is all multiply. So I have a 5, what's this? You got a calculator, you don't know. What is 3 to the 4th? 81. And then don't forget, you also have a -1. This is a -1. If it helps you, write it as a -1. That's a -1 to the 1st. So that's -1. So what happens when I multiply all those together? You have a calculator, go ahead. What is it? Negative 405 x to the 4th y. Okay, I'm going to do one more with you, and then I'm going to do the rest of them on your own. So we're on to the next term. This is all multiply, okay? So it's a 10 times a what? 27 times a what? This is -1 squared. So -1 times -1, 1. So I got 270 x cubed y. All right, try the last two. What?
Is it y squared?
It is, thank you very much, Scout, thank you, it is y squared. Alright. Do the rest of it, see what you come up with. Okay, anybody have this, where we at, this one right here, anybody have this one? What did you get for this guy? Negative 90x squared y cubed, I think you're exactly right, because we have a 10, a 3 squared, which is a 9, and a negative 1 cubed, which is negative 1. Any question about that? Everybody get that okay? All right, what'd you get for this one? 15 xy to the 4th. Because you have a 5, a 3, and a positive 1. A negative 1 to the 4th power is positive. And then what's your very last term here on the end? Negative y to the 5th. Oh boy, look at this next one. Boy, that's a biggie. But luckily, we don't want the whole thing, because it would be the whole board. We don't want the whole thing, it's just the 3rd term. Okay, I'm still a little bit concerned. Okay, so Scout says one option that I have is to this is what I did for the 5th power. So I'm gonna have to get some more rows going here and get down to the 10th row for this problem, right? So that's one option. This test is short, you'll have plenty of time to do that if that's the way you want to do it. Does anybody remember though the observation we made? What is the connection between Pascal's triangle and the rest of this chapter? Jacob?
Add 1 on the side.
Well, that's how you build the triangle. But these are actually, one day we did it in class, these are actually the combination numbers. So this number right here is actually 5C5. And this is 5C4, 5C3, 5C2, 5C1, 5C0. And the next row would be 6C6, 6C5, 6C4, da 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 da. So if you want to build the triangle all the way down to the 10th row, that is absolutely fine. You can do that. You can also recognize though that the 10th row is 10C10, 10C9, 10C8, 10C7, da 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 da, all the way down to 10C0. That's what the 10th row is going to be. I like to do that because it's a little more efficient than writing out all those rows. But again, you can write out all the rows and be just fine. The 3rd term is going to be that one. So the third term is gonna be 10C8, oh Lord, which is 45. So if you write out all the triangle, that number will be 45. Alright, so again, say it one more time. Write out the triangle if you wish. If you don't want to take the time to write out the entire thing, know that every row is the combination numbers. So, for example, the 7th row would be 7C7, 7C6, 7C5. It counts down just like the exponents do. Alright, next to every number is going to go your variables, which is 2x and negative 3y in this problem. 2x and negative 3y. Now I'm going to put on my exponents. Well, my first exponent in the 10th row would be 10, and then 9, and then 8. So this exponent is an 8, which makes this one a 2, because they gotta add up to 10. Now that's a multiplication. So I have a 45, a 2 to the 8th, which is 256. Better check that. And then negative 3 squared, which is 9. So the number, all that's multiplied, is 103,680 x to the 8 y squared.
Where did we get the 8? Let's see it again.
We counted our exponents down, 10, 9, 8. All right, how can you calculate Hc5 by hand? I don't need this anymore, so I'll get rid of this. What's our formula for 8C5?
You do.
8 factorial, always, no matter if it's a C or a P, you start with that. 8 factorial over 3 factorial, 5 factorial, in either order game, it doesn't matter, that's fine. So when we do a C problem, it's this number factorial over the subtraction and this number. There's two things down there, the subtraction and this number. Now, by hand, this is by hand. So 8 factorial I got 56, did you? Now I'm okay, sometimes we're left with a whole bunch of stuff and that's when you can go to your calculator, but I need to see the fraction, the setup here, and I need to see the canceling. And then if you need the calculator for the arithmetic. Let's go ahead and do 8P5 real quick just to make sure we remember the difference. What's 8P5? That would just be 8 factorial over 3 factorial, because when you do a P problem, there's only one thing in the denominator, and it's the subtraction. All right, that's just something else to remember. Okay, 15. Alright, so we've got, what? I don't know whatever M and N stand for. And we know that the probability of M is 0.62, the probability of N is 0.75, and the probability of both is 0.51. So, where do we start?
151.
Put the 0.51 in the middle. That's the overlap. That's the and. Okay? Now we can fill in the rest. If the whole M is 62, then this part will be 11, is that right? And if the whole N is 75, this will be 24? What do those add up to? 86, which means what? There's 14 out here. Because the whole thing in a probability question, the whole thing has to be 100. Just like your little V's and your tree diagram. Okay, what's the first question? A, what's that asking me? What's the probability of only M? I'm in M, but I'm not in N. So that would be 0.11. And then what's B? Neither one. What's the probability of neither one? And that would be your 0.14. Got it? RJ? Got it? Okay, again, I've used the same chart, but the questions are different, so here we go. What is the probability that both students will like English? Both like English. What's the probability? Be 0.2 times 0.3. English times English. So 0.06. First likes math, and second likes art. I got 0.06 for that one also. Are we all on the same page here? Easy. Neither likes science. What am I multiplying if neither likes science? So not science, not science. 0.9 times 0.8. 0.72. One will like science and the other will like math. So science and math, or math and science. Because I don't know where the math student is coming from, if he's in class 1 or class 2. So I have to look at both of them. So science and math is 0.1 times 0.4. And then math and science. Okay, so that's 0.04 plus 0.12. Did you get 0.16? Perfect. Practice test 3 in the books. All right, I thought we might finish a little early, so I threw together a few more problems here. So what I want you to do now is kind of look this over both sides. This extra practice problem is all nothing new. And what you need, we're not gonna get them all done. We don't have time to get the whole thing done. So as you look at the paper, what do you think we need to practice again? What would you like to practice again as you look at the paper? What are you gonna miss tomorrow? Jocelyn?
1.
Number 1, so there's another expansion. Oh shoot, I erased Pascal'S Triangle. You've still got it on your paper there, Pascal'S Triangle. Because what's the first thing I need to do? Write down the numbers, right? And where are the numbers coming from? The fourth row of Pascal'S Triangle. Now, I do this for a living, so I have that memorized. You don't, but you know how to find it. 10 minutes ago, everybody in this room said they knew how to find Pascal's Triangle. Okay, so this is the fourth row. All right, what's next? Once I get my numbers written down. Variables. So in this problem, it's x and negative 2y. So x and negative 2y. And now I'll do my exponents, starting with 4 on the first variable. So 4, 3, 2. And now I'm ready to start simplifying. Take out anything to the 0, so it'll be 1 on each end. Just take those out. What do I have here? X to the 4. Now be careful here. This is multiply. This is not a subtraction. It's actually going to become a subtraction, because when I multiply 4 times negative 2, I'm going to get negative 8. But be careful, what am I multiplying here? My 6 is going to be multiplied by what? 4. So 24 x squared y squared. Negative 2 times negative 2 is positive 4. What am I multiplying here? By 4. And what's this? Negative 8. So that's going to be negative 32 xy cubed. And what's on the end? 16 y to the 4th. Negative 2 times negative 2 times negative 2 times negative 2. Okay, Jocelyn, is that okay? Good. All right, what else? I'm not going to stop talking, so you might as well make it productive for you. What do you need me to? 4. Huh? 4? What is the probability? Okay, so it's a probability, it's going to be a fraction, of getting 2 diamonds and 3 clubs if you are dealt 5 cards. What's your denominator? 52C5. Now, I want 2 diamonds and 3 clubs. So 2 diamonds and 3 clubs. All right, how do I get 2 diamonds? How many diamonds are there in the deck? 13. And I need to pick 2 of them. How many clubs are in the deck? 13. And I need to pick 3 of them. So here are my 2 diamonds. There are 13 diamonds, choose 2. 13 clubs, choose 3. I got 0.007. If we round in the nearest thousand, I got 0.007. Did you? Perfect. All right, another one. Come on. What are you gonna miss on test day? Come on. Okay,
Number 3.
3. How many ways can a committee of 2 Republicans and 3 Democrats be chosen from a group of 10 so I've got 10 Republicans and 16 Democrats, and I am going to pick 2 of these and 3 of these. So this is a lot like what we just did, picking diamond or whatever it was, hearts and spades or whatever it was. This is very similar. What's your idea, Gio?
10C2
10C2.
plus 16C3.
Okay, now I love the setup, but what should go in here? A times, because we're picking Republicans and Democrats for our committee. Would you agree with me, Gio? That should be a times? Yes. Otherwise, it's absolutely perfect. We have 10, we're picking 2. 16, we're picking 3. The only time we add is when what? When do we add? When it's this or this. When we're doing one or the other, we add. Otherwise, we're going to multiply. Okay, one more. Okay, let's. Okay, so yeah, we can do we love math. All right, so we love math. All right, so we are going to arrange those letters. Do you think if I say that enough, you will eventually love math? All right, so here we go. How do we start? What do we do first? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just count them up. So we're going to start with 10 factorial, right? Now, I went ahead and drew a line. I'm assuming there are repeats. Yeah, I see a couple of E's. So 2 factorial for the E's. Is that it? All right, so no parentheses necessary, but feel free to put them in. 10 factorial. I got 1,814,400. Did you? Okay, we got time to do one more. Let's do 7. 7 looks like a lot going on there. Pretend for a minute that the Venn diagram wasn't there, because on the test it won't be. Can you read the question? 30 students in the class liking English and math. Can you sense this should be a Venn diagram problem, even if the picture weren't there? So, we've got math and English, 30 kids. 18 like English, 20 like math. What's the probability of choosing a student who only likes math? All of the students like at least one of them, so there's nobody out here that only likes them. All right, quickly, where do we start? There's 8 overlap because these add up to 38, which means this has to be 12 and this has to be 10, right? Now this is a probability question. This says I'm going to reach in and grab a kid. What's the probability of getting somebody who only likes math? Well, aren't these the kids that only like math? So the answer would be 12 over 30. 12 30ths. And reduce that. 12 30ths like only math. Or is the percentage. All right. Feel free to stop by after school. I will be subbing